Welcome to the CompTIA Project Plus prepcast by baremetalcyber.com. Agile is not a single methodology, but a family of frameworks that share common values and principles. Each framework presents a disciplined way to plan, execute, and adapt work, while still honoring continuous feedback and incremental delivery. In information technology settings, these frameworks help teams respond to change without losing control of quality or schedule. Knowing that Agile is an umbrella and not one fixed recipe sets the stage for comparing options and choosing a structure that matches the size, complexity, and goals of your project. Different Agile frameworks apply shared values in different ways depending on team size, product scope, and organizational constraints. Some emphasize iteration cadence and clearly defined roles, while others focus on technical rigor and engineering practices. At scale, certain frameworks add coordination layers to align multiple teams and synchronize delivery. Understanding these variations allows you to judge how much process guidance you need, how tightly to coordinate schedules, and which mechanisms will best maintain quality while change is still expected. Distinguishing among frameworks matters because your selection affects risk exposure, speed of delivery, and governance. A team facing evolving requirements may need short iterations and constant stakeholder feedback, while a regulated environment may require formal checkpoints and baseline control. By mapping framework characteristics to your constraints, you improve clarity around responsibilities, reduce handoff friction, and create a learning rhythm that keeps value flowing while protecting scope, time, and budget commitments. Scrum is among the most widely used Agile frameworks in software and information technology projects. Work is organized into stable, short cycles called sprints, and each cycle aims to produce a usable increment of the product. Scrum builds transparency through simple artifacts and recurring events, so progress is visible and priorities can be reassessed frequently. The framework is intentionally lightweight, which makes it adaptable across industries while still providing a consistent operating rhythm. Sprints are time-boxed, usually 2 to 4 weeks, which creates a reliable heartbeat for planning and delivery. Short cycles reduce the distance between idea and feedback, allowing the team to gauge value early and correct course before large investments are sunk. This cadence also encourages right-sized work, clearer estimation, and steady improvement in forecasting, since the team gains experience with a repeating window for commitment and review. Scrum relies on a small set of defined roles, ceremonies, and artifacts that guide delivery and review. The roles keep decision-making clear, the ceremonies create focus points for planning and reflection, and the artifacts provide a shared source of truth about what is being built and why. This combination supports accountability without heavy bureaucracy, which is why teams often adopt Scrum when they want structure that still leaves room for change. In Scrum, the product owner defines and prioritizes the work to be done. This role captures stakeholder needs, expresses them as backlog items, and continuously orders those items by business value and risk. By making priority decisions visible, the product owner ensures that the team invests effort where it will have the greatest impact, while also clarifying what can be deferred without endangering the release goals. The Scrum Master facilitates the process and removes impediments so the team can maintain momentum. This role coaches the group on Scrum principles, protects the sprint from unnecessary disruptions, and helps resolve blockers that slow delivery. By focusing on flow and team health, the Scrum Master supports predictable outcomes while encouraging sustainable pace and continuous improvement across iterations. The development team is cross-functional and self-organizing, which means members collaborate to complete sprint goals without relying on external handoffs. Skills are combined to design, build, test, and integrate working increments inside the sprint window. This approach promotes shared ownership of quality and reduces waiting time between steps, which leads to faster feedback loops and more resilient delivery practices. Scrum artifacts keep work visible and aligned with value. The product backlog is the ordered list of features, fixes, and enhancements that could be delivered, expressed at the level of detail appropriate for planning. It remains dynamic and is refined as understanding grows, which allows priorities to shift without derailing the project. Clear ordering in the backlog ensures that the team is always working on the most valuable items first. The sprint backlog is the subset of backlog items selected for the current sprint, along with the plan for how the team will complete them. Because this plan is owned by the team, it can be adapted during the sprint as new information emerges, while still protecting the sprint goal. This focused scope helps the team maintain a consistent work rate and protects quality by avoiding mid-sprint scope inflation. The increment is the sum of all completed work at the end of a sprint, potentially shippable and ready for stakeholder review. A clearly defined standard of done ensures that the increment meets quality expectations, including testing and integration, before it is presented. By treating the increment as the primary measure of progress, Scrum keeps attention on working outcomes rather than intermediate documents. Scrum ceremonies create a steady rhythm of planning, coordination, feedback, and improvement. Sprint planning sets the sprint goal and defines the backlog items the team commits to deliver, aligning scope with capacity. The session clarifies acceptance criteria and surfaces dependencies early, which reduces surprises during execution and supports consistent delivery. Daily stand-ups keep the team synchronized and highlight blockers quickly. Each member briefly states what was done, what will be done next, and what issues are in the way. This rapid check-in discourages hidden work, reveals capacity risks, and prompts timely support or rebalancing within the team, which helps maintain forward progress without lengthy meetings. Sprint reviews and retrospectives support continuous feedback and improvement. In the review, stakeholders see the increment and provide input that can change priorities for future sprints. In the retrospective, the team inspects its own process and agrees on small, actionable adjustments. Together, these events ensure that the product evolves toward real needs, while the delivery system itself becomes more effective over time. Extreme programming, often referred to as XP, is an agile framework that emphasizes engineering discipline and technical excellence. It is tailored for environments where requirements change rapidly and quality must remain high despite frequent updates. While Scrum focuses on roles and cadence, XP focuses on practices that improve code quality, speed learning, and keep the design simple enough to evolve safely as knowledge grows. XP is grounded in values of communication, simplicity, feedback, courage, and respect. These values foster frequent collaboration, encourage small, safe changes, and build trust within the team. XP promotes small releases so that working software reaches users often, shared code ownership so knowledge spreads and bottlenecks are avoided, and constant collaboration so the team can react quickly when needs or constraints shift. XP technical practices reinforce its quality goals. Test-driven development requires writing a test before the code that satisfies it, which anchors design decisions to verifiable behavior and reduces defects early. Pair programming places two developers at one workstation so ideas are reviewed in real time, knowledge is shared, and complex problems are solved more effectively. Refactoring keeps the codebase clean and adaptable, so new features can be added without accumulating fragile complexity. The Scaled Agile Framework, known as SAF, extends agile principles to large organizations that must coordinate multiple teams and complex delivery streams. It introduces structured planning cycles and additional roles that align execution to strategy while preserving iterative development at the team level. By standardizing cadence and synchronization points, SAF helps large enterprises deliver value predictably without abandoning responsiveness to change. SAF organizes work across several layers so coordination remains explicit. At the team level, Scrum or other Agile teams build product increments within sprint cycles. At the program level, groups of teams collaborate as Agile release train units, sharing a common mission and synchronized schedules so cross-team dependencies are managed proactively. At the portfolio level, funding and strategy guide which value streams are prioritized, ensuring that execution remains tied to organizational goals. SAF planning and events align calendars and expectations across many teams. PI planning brings all contributors together at regular intervals to agree on objectives, identify risks, and map dependencies for the next increment. Ongoing Agile release, train sync sessions keep progress visible and issues surfaced between planning windows. Inspect and adapt workshops close each increment with data-based reflection and corrective actions, sustaining learning at enterprise scale. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. In SAFe, roles and responsibilities extend beyond those found in team-level Agile frameworks. The release train engineer facilitates program-level execution, ensuring that all teams within an Agile release train are aligned, obstacles are addressed promptly, and cadence is maintained. Product management operates at a higher level than the team product owner role, overseeing priorities and coordinating features across multiple teams. Business owners act as senior stakeholders, providing strategic guidance, approving priorities during planning, and ensuring that outcomes align with enterprise objectives. Using SAFe in large organizations offers tangible benefits. It enables consistent Agile practices across geographically distributed teams and departments, creating a common language for planning, delivery, and reporting. This alignment allows multiple teams to work toward shared objectives without drifting apart in focus or timing. Additionally, SAFe balances agility with enterprise governance, ensuring compliance with budgeting cycles, risk oversight, and executive reporting requirements while still enabling iterative delivery at the team level. However, SAFe does introduce additional complexity compared to smaller-scale Agile frameworks. Implementing it successfully requires a certain level of organizational maturity, experienced leadership, and a willingness to embrace cultural change. Smaller teams or projects with straightforward deliverables may find SAFe unnecessarily heavyweight. It is most effective when the size and complexity of the work demand a structured coordination model. Comparing Scrum and XP highlights how frameworks can complement one another. Scrum excels at creating predictable delivery cycles, structuring team collaboration, and engaging stakeholders in regular review. XP focuses on the technical side, raising the quality of the product through disciplined coding practices, automated testing, and continuous refactoring. Many development teams use Scrum as their overall process framework while adopting selected XP practices to enhance quality and maintain adaptability at the engineering level. Scrum and SAFe also differ in scope. Scrum is designed for single teams or small groups of teams that can operate with minimal overhead. It prioritizes agility, rapid feedback, and self-organization. SAFe incorporates Scrum's iterative cycles but scales them across programs and portfolios, adding layers of planning, coordination, and governance. This makes SAFe suitable for enterprises where multiple teams must deliver interdependent work within the same timeframes. XP is best suited for environments where requirements change rapidly and technical quality is paramount. It thrives in situations where automated testing, frequent releases, and collaborative coding can be sustained without sacrificing speed. This makes it ideal for small, co-located teams with strong technical discipline, but elements of XP can be adopted by larger organizations when quality concerns require it. Scrum works best when the work can be broken into clear, deliverable increments and when stakeholders are available for frequent feedback. It requires teams to be empowered to self-organize, commit to achievable sprint goals, and continuously improve their processes. Its straightforward structure makes it a common starting point for organizations moving into Agile delivery. SAFe becomes relevant when multiple Agile teams must coordinate deliverables, share dependencies, and align with enterprise-level priorities. It supports complex programs where centralized coordination ensures resources are allocated effectively and work is sequenced to deliver maximum strategic value. Organizations looking to apply Agile principles across the enterprise can use SAFe to preserve adaptability while meeting governance and compliance obligations. Choosing the right Agile framework depends on the scale of the work, the complexity of the product, and the maturity of the organization. Small teams may find that Scrum or XP provides enough structure without unnecessary overhead. Large enterprises managing portfolios of work may require the additional layers offered by SAF. In many cases, blending elements from multiple frameworks produces the best results, as Agile itself values adaptability, including in how its practices are applied. Framework compatibility is an important consideration. Agile frameworks are not mutually exclusive. Many organizations use Scrum for iteration planning while adopting XP practices for coding and testing. Others implement SAF for enterprise alignment but maintain team-level Scrum events and artifacts. The flexibility to tailor frameworks to your context ensures that process design serves the work rather than forcing the work to fit a rigid process. In summary, Scrum, XP, and SAFA each offer structured yet adaptable ways to apply Agile values and principles in different contexts. Scrum provides a simple, repeatable cadence for small to mid-sized teams. XP deepens engineering quality and technical agility. SAF scales Agile across the enterprise while maintaining alignment with strategic goals. Understanding when and how to use these frameworks, individually or together, will prepare you for both the PK 0-005 exam and the realities of managing Agile projects in varied IT environments. Thank you for listening. Please follow baremetalcyber.com on social media and check out our books at cyberauthor.me.